The purpose of this video is to give you some advice on how to use exponents. So I've listed the major rules that we're going to be using and go over some hints on what to look for. The first rule that we've used is the product rule. The product rule is when you are multiplying terms with the same base and exponents. When you are multiplying, you actually add the exponents. Here's an example. 4x squared times 3x cubed. You multiply the coefficients, the 4 times the 3. The exponent only applies to the x. It does not apply to the 4. This exponent of 3 only applies to the x. It does not apply to the 3. So when we multiply the x squared times the x cubed, we add those exponents together and get x to the 5th. So when we multiply these two terms together, the result is 12x to the 5th. The quotient rule is when you are dividing terms that have the same base and have exponents. When that is the case, you subtract the exponents. So here's an example, 3x to the 5th over or divided by 6x squared. You divide the 3 and the 6 both by 3, the common factor, and you get 1 in the numerator and 2 in the denominator. The x to the 5th and the x to the 3rd, you subtract the exponents. So you get x to the 5 minus 2, which gives us x to the 3rd. We end up with x to the 3rd over 2. The power rule is when we are raising a term with an exponent to another exponent. And basically, we can use the meaning of exponents to figure out what that results. So we've got 3x squared, that whole term, raised to the 3rd power. The meaning is just 3x squared times 3x squared times 3x squared, because that's what raising to a power actually means. When we multiply them together, we can then use this rule here, going back to the product rule, and we get 3 times 3 times 3, which is 27, and x squared times x squared times x squared. Remember, when we are multiplying terms, we add the exponents, and we end up with x to the 6th. Another way we can apply this power rule is to distribute that external power to each term inside. So it's 3 to the 3rd power, which gives us 27, or x squared to the 3rd power, which gives us x to the 6th. We multiply the exponents together. That's the only time we multiply exponents. The power of a quotient. So we've got a quotient or a fraction, and we've got 5 over a raised to the 2nd power. That external power applies to both the 5 and the a, and we get 5 squared over a squared, which is equal to 25 over a squared. This is one of the most important rules and meanings that I want to emphasize to you. This term here is -4 to the 2nd power. The power applies to everything within the parentheses. So what this means is -4 times -4. And that gives us a positive 16. I didn't mean to put that there. Let me go back. That is equal to positive 16. Now this term, the exponent of 2, does not apply to -4. This is not -4 to the 2nd power. This is the opposite of 4 squared. The exponent only applies to what's directly below it, the number 4. It does not apply to the negative sign. If we wanted to apply to the number -4, we have to write it like this. We have to write the -4 in parentheses. This is actually equal to, let's see if I can type this one correctly. That's equal to the opposite of 4 times 4. And this gives us negative 16. I hope that makes sense. And if you have any questions about that, please review that. That's a really important information, and it's a place where I see a lot of mistakes taking place. Now let's move on to negative exponents. What a negative exponent means is take the reciprocal. It has nothing to do with a negative number. It is not negative. It just means take the reciprocal. So when we have x to a negative third power, it means 1 over x to the third. When you take the reciprocal, that essentially removes the minus sign in the exponent. If we have a fraction that we're taking a negative power of, we just flip the fraction. So a over 5 to the negative 2 power means 5 over a, we flip it, take the reciprocal, and we remove the negative sign from the exponent and get 5 over a squared. And then again, using the meaning of an exponent, that just means 5 squared over a squared, or just 25 over a squared. Here we have a fraction which only has that negative power in the denominator. There are two ways we can look at this. We can take the actual meaning, which means 3 divided by y to the negative fourth, or 3 divided by 1 over y to the fourth. Well, now it's just a division problem involving fractions. So we can rewrite it as 3 over 1 times the reciprocal of this fraction, y to the fourth over 1. We multiply straight across, and we just get 3y to the fourth over 1, or just 3y to the fourth. When we have a negative exponent applying to a rational number or a fraction, we just flip it. So when we apply the negative exponent to this fraction, we basically are taking the reciprocal of this fraction and making it 3 over 5x squared. And then that takes away the negative sign in the exponent, so we have that fraction raised to the third power. To complete this, we then apply that third power to both the numerator and the denominator. So it becomes 3 to the third power, which is 27, 5 to the third power, which is 125, x to the third power, which is just x to the third power, and y squared to the third power, which becomes y to the sixth. Now here's a fraction with lots of negative exponents. An easy way to deal with this is to basically move a value that has a negative exponent to the denominator if it starts out in the numerator, and move it into the numerator if it has a negative exponent in the denominator. So a to the negative 2 power, the a squared goes to the denominator, b to the negative third power goes to the denominator as b cubed, c to the negative fourth power goes to the denominator as c to the fourth. Now there's nothing left in the numerator right now, so it doesn't all become a denominator. That 1 remains. There's always a 1 to keep that place in the numerator. Now because we have negative exponents in the denominator, those move up to the numerator. So x to the negative 1 becomes just x to the first power, or x in the numerator. Y to the negative 2 power in the denominator moves up to the numerator as y squared. I hope that makes sense and it's not too confusing. If you have any questions on any of these exponential hints, please let me know so I can help you through it. Thanks.